Hello everyone. Today we will study rectangular coordinate system. What is the rectangular coordinate system? Let's think of this. In a plane, consider there's a horizontal line and there's a vertical line. In general, two lines will intersect at one point. Let's call this point the origin. In general, we use 0 to represent origin. Numbers to the right side are positive. Positive 1, positive 2, positive 3, positive 4, and so on. Numbers on the left side are negative. We have negative 1, negative 2, negative 3, negative 4, and so on. Numbers above 0 are positive. Positive 1, positive 2, positive 3, positive 4. And numbers below 0 are negative. Negative 1, negative 2, negative 3, negative 4, and so on. These two lines have a name. The horizontal line here is called the x-axis. And the vertical line is called the y-axis. That's the x-axis, that's the y-axis. And here we can see that two lines divide the plane into 4 different regions. We call them quadrants. Here we have 4 different quadrants. This is the first quadrant. This is the first quadrant called quadrant 1. And this is the second quadrant, quadrant 2. This is the third quadrant, quadrant 3. And this is the fourth quadrant, quadrant 4. So, x and y axis divide the plane into 4 different quadrants called quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Next, let me introduce ordered pairs. Ordered pair looks like this. X comma y. In general, it looks like this. X comma y. So in general, we use ordered pairs to represent points in the coordinate plane. Note, every point in the plane can be represented by an ordered pair. Every point in the coordinate plane is called an SY plane. Every point in the SY plane can be represented by an ordered pair, by a unique ordered pair. And every ordered pair represents a unique point in the SY plane. Every ordered pair represents a unique point in the SY plane. Also, for order pair, x comma y, the first number always represents x coordinate. The second number always represents y coordinate. The first value always represent the x coordinate. And the second value let me put it here, always represent the y coordinate. For order pair x and x comma y, the first value always represents the x coordinate, and the second value always represents the y coordinate. Next, I'll show you an example. Plot each of the following points in the xy plane. We know that in the xy plane, every order pair represents a point. Here, I'll show you how to plot these order pairs in the xy plane. Let's first of all draw an xy plane. The horizontal line always represents x-axis, and the vertical line always represents the y-axis. The intersection is 0. That's called origin. Numbers on the right side are positive. Numbers on the left side are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's plot the points. First point, 2, 4. X coordinate is 2. Y coordinate is 4. The first number always represents x coordinate. Second number always represents y coordinate. So here in the point 2, 4, the x coordinate is 2 and the y coordinate is 4. How do we plot 2, 4? Usually we plot x coordinate first. X coordinate is 2. If the y coordinate is positive, go up. If the y coordinate is negative, we go down. Here the y coordinate is positive 4. So go up by 4 units. 1, 2, 3, 4. We are here. That's the point 2, 4. So for the point 2, 4, we plot the x coordinate first. X coordinate is 2. If y coordinate is positive, we go up. If the y coordinate is negative, go down. Here the y coordinate is positive 4. So go up by 4 units. 1, 2, 3, 4. That's the point 2, 4. Next point, -1, 3. X coordinate is -1. Y coordinate is 3. So let's plot the x coordinate first. X coordinate is -1. That's here. Y coordinate is positive 3. So go up by 3 units. 1, 2, 3. That's the point -1, 3. Next point, -3, -4. -3, -4. S coordinate is -3. Y coordinate is -4. So let's plot S coordinate first. S coordinate is -3. It's here. Now look at the Y coordinate. If Y coordinate is negative, we go down. Here the Y coordinate is -4. So go down by 4 units. 1, 2, 3, 4 is here. That's the point -3, -4. Next, 3, -2. That means S coordinate is 3. Y coordinate is -2. So plot S coordinate first. 1, 2, 3, that's here. Y coordinate is -2. So go down by 2 units. 1, 2. That's the point 3, -2. Next point 1.5, 3.5. Here S coordinate is 1.5. Y coordinate is 3.5. So plot S coordinate first. 1.5 somewhere here. 1.5 somewhere here. Y coordinate is 3.5. So go up by 3.5. 1, 2, 3.5. So that's the point. That's the point 1.5, 3.5. That's the point 1.5, 3.5. Next point, -2.1 and -1.2. Let's plot S coordinate first. Here the S coordinate is -2.1. That's somewhere here. A little more than 2, but it's very, very close to -2. That's the S coordinate. Y coordinate is -1.2. It's negative, so go down. Go down by -1.2. That's -1, that's 1.2. So that's the point, -2.1, -1.2. Next point, 0, 5. S coordinate is 0, Y coordinate is 5. So plot S coordinate first, it's here. S coordinate is 0. Y coordinate is 5. So move up by 4 units. 1, 2, 3, 4, 5. We are here. So that's the point, 0, 5. Next point, 0, -2. 0, -2. S coordinate is 0. Y coordinate is -2. S coordinate is 0. If Y coordinate is -2, we move down by 2 units. 1, 2. That's the point, 0, -2. Next point, 1, 0. S coordinate is 1. Y coordinate is 0. S coordinate is 1. Y coordinate is 0. Where do I move? We know that if Y coordinate is positive, we go up. If Y coordinate is negative, we go down. But if Y coordinate is 0, we stay here, don't go anywhere. If Y coordinate is positive, we move up. If Y coordinate is negative, we move down. But if Y coordinate is 0, we stay the way it is, stays here. That's the point, 1, 0. Next point, -5, 0. -5, 0. The S coordinate is -5. Y coordinate is 0. So let's plot S coordinate first. S coordinate is -5. Y coordinate is 0. If the Y coordinate is positive, we go up. If the Y coordinate is 0, we go down. But if Y coordinate is 0, we stay here. So that's the point, -5, 0. Now let's observe the points in the x-axis and the y-axis. Here we can see that for the points in the x-axis, their y coordinate is 0. And for the points in the y-axis, For the points in the y-axis, the s-coordinate is 0. So keep this idea in mind. Note, for all points in the s-axis, their y-coordinate are 0. And for all points in the y-axis, their s-coordinate is 0. Their s-coordinates are 0. Keep this idea in mind. Next, let me introduce midpoint. The S1, Y1 and S2, Y2 be 2 points in the SY plane. Their midpoint is defined as the point with the coordinates S1 plus X2 over 2, comma Y1 plus Y2 over 2, which means in the midpoint, the S-coordinate is the average of these 2 S-coordinates here, and the Y-coordinate is the average of these 2 Y-coordinates here. That's how we define midpoint. Next, let's look at an example. Plot each of the following points and their midpoint. So first pair is -2, 4, 4, 0. Let's first of all find their midpoints. In general, we call the first point S1, Y1. We call the second point S2, Y2. So let's compute their average. Let's compute the average of the S-coordinate and the average of the y-coordinate. S1 plus S2 over 2 equal to -2 plus 4 over 2, which is -2 plus 4 is +2 over 2, that's 1. And then we compute y1 plus y2 over 2. That's y1, that's y2. I get 4 plus 0 over 2, which is 4 over 2. 4 over 2 is 2. So the midpoint is 1, 2. So the midpoint for these 2 points, the midpoint is 1, 2. Next, let's plot the points. Number in the middle is 0. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. First point, -2, 4. S-coordinate is -2. Y-coordinate is 4. That's the point, -2, 4. Next point, 4, 0. S-coordinate is 4. Y-coordinate 0 is here. That's the point, 4, 0. Midpoint is 1, 2. S-coordinate is 1, y-coordinate is 2. That's the midpoint. So here we can see that if we connect the point, we can see that this point is in the middle of these 2 points. That's the midpoint. Next example. First point is 1, -5. Second point is -3, -1. So usually we call the first point S1, Y1. Call the second point S2, Y2. In order to compute the midpoint, let's find the average of an x coordinate and the average of y coordinate first. For the average of x coordinate, we compute S1 plus S2 over 2. That's 1 plus negative 3 over 2. 1 plus negative 3 is negative 2. Negative 2 over 2 is negative 1. And then for the y coordinate, we compute y1 plus y2 over 2. That's y1, that's y2. I get negative 5 plus negative 1 over 2. Negative 5 plus negative 1 is negative 6. Negative 6 over 2 is negative 3. So the midpoint is negative 1 comma 3. Negative 1 comma negative 3. That's the midpoint of these 2 points. Next, let's plot the points. That's an x-axis. That's an y-axis. Number in the middle is 0. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's plot the points. First point 1 comma negative 5. S is 1, y is negative 5. So 1 is here, go down by negative 5. That's the point 1 comma negative 5. The second point is negative 3 comma negative 1. X coordinate is negative 3, y coordinate is negative 1. It's here. That's the point negative 3 comma negative 1. The midpoint is negative 1 comma negative 3. The midpoint is negative 1 comma negative 3. So x coordinate is negative 1, y coordinate is negative 3 is here. If we connect the point, we can see that that's the midpoint of these 2 points. Next example. First point is negative 3, negative 4. Second point is negative 5, negative 2. In general, we call the first point S1, Y1. We call the second point S2, Y2. First of all, we find a midpoint. We find average of x and y coordinates. So S1 plus S2 over 2. Find the average for the s coordinates. For the midpoint, we find an average for the x coordinates and the y coordinates. S1 plus S2, we have negative 3 plus negative 5 over 2. Negative 3 plus negative 5 is negative 8. Negative 8 over 2 is negative 4. Next, we compute the average of y coordinates. Y1 plus Y2 over 2 is negative 4 plus negative 2 over 2. Negative 4 plus negative 2 is negative 6. Negative 6 over 2 is negative 3. So that's the midpoint. Negative 4 comma negative 3, that's the midpoint. Now plot the points. That's an x-axis, that's an y-axis. Number in the middle is 0. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's plot a point here. First point is -3, -4. X coordinate is -3. Y coordinate is -4. It's here. That's the point -3, -4. Second point, -5, -2. X coordinate is -5. Y coordinate is -2. X coordinate is -5. Y coordinate is -2. It's here. That's the second point, -5, -2. Next, plot the midpoint. Midpoint is -4, -3. X coordinate is -4. Y coordinate is -3. Somewhere here. That's the midpoint, -4, -3. If we connect the point, we can see that that's the midpoint of these 2 points. Next example. Find the midpoints first. Let's call the first point S1, Y1. Call the second point S2, Y2. Then find the average of the S coordinates. Find the average of the S coordinates. I compute S1 plus S2 over 2, which is 4 plus 3 over 2. 4 plus 3 is 7. 7 over 2, it can be rewritten as 3.5. 7 over 2 can be rewritten as 3.5. Next, find the average of the Y coordinates. I compute Y1 plus Y2 over 2, which is -1 plus -3 over 2. -1 plus -3 is -4. -4 over 2 is -2. So the midpoint is 7 over 2, -2. Midpoint is 7 over 2, -2. In general, when we write an answer, we don't use mixed number, we use improper fractions. In general, when we write an answer, we use improper fractions, we don't use mixed number. So only put improper fraction here. Don't write mixed number as your final answer. For your final answer, always write the improper fractions. Now, but when you plot the points, we use the mixed numbers. When we plot points, we use mixed number. Now let's plot the points. That's an S coordinate. That's an S-axis. That's an Y-axis. Number in the middle is 0. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. And numbers below 0 are negative. Let's plot the points. First point, 4, -1. X coordinate is 4. Y coordinate is -1. It's here. Second point, 3, -3. X coordinate is 3. Y coordinate is -3. It's here. Then the midpoint, 7 over 2. What's 7 over 2? 7 over 2 is the same as 3.5. So S coordinate is 3.5. S coordinate is 3.5. Y coordinate is -2. It's here. That's the midpoint, 7 over 2, -2. If we connect a point, we can see that that's the midpoint of these 2 points. So in general, when we write an answer, we use improper fractions. But when we plot points, we have to use the mixed number. When we plot point, we need to use the mixed number. But when we write the final answer, we need to use improper fractions. Next, let me introduce distance between 2 points. Let S1, Y1 and S2, Y2 be 2 points in SY plane. Then the distance between these 2 points is defined as d equal to square root of S2 minus S1 square plus Y2 minus Y1 square. That's how we define distance between 2 points. But how does this definition make sense? In order to understand this definition better, let's think of Pythagorean theorem. Pythagorean theorem says, for any right triangle with 2 legs A and B and hypotenuse C, we always have C squared equal to A squared plus B squared. For any right triangle with 2 legs A and B and hypotenuse C, we always have C squared equal to A squared plus B squared. Now, we try to derive the distance formula using Pythagorean theorem. Think of 2 points. First point is S1, Y1. Second point is S2, Y2. We try to find distance between these 2 points. We try to find distance between these 2 points. Now, try to form a right triangle based on these 2 points. Let's draw a vertical line passing through the second point and draw a horizontal line passing through the first point. Here we can make a right triangle here. That's a right angle. So this is a right triangle. In this right triangle, we can see that this distance, that's a rise. This distance is called a rise. This distance is called a long, sorry. This distance here is called a long. This side is called long. And this side is called rise. This is long, this is rise. So this is a right triangle. We know that these 2 sides, they are legs, and D is the hypotenuse. Using Pythagorean theorem, we have D squared equal to the long square plus the rise square. But what's the long? What's the rise? What's the long? What's the rise here? Here, long is a horizontal change. Long is a horizontal change between these 2 points. Horizontal change is the change of x. Long is a horizontal change between these 2 points. Horizontal change is the change of x. So long equal to delta x. Delta x is the change between x. x2 minus s1. That's delta x. That's the change of x. x2 minus s1. That's the change of x. What's rise? Rise is the change of y. Rise is the change of y. That's the vertical change. Rise is the vertical change. So that's the change of y, delta y. Delta y is y2 minus y1. Use the second point, second y coordinate minus the first y coordinate. So long is x2 minus s1. Rise is y2 minus y1. If we plug in, we have d squared equal to x2 minus s1 square plus y2 minus y1 square. If we try to solve for d, we can take square root on both sides. So d equal to square root of x2 minus s1 square plus y2 minus y1 square. That's how we get d. So that's the distance formula between 2 points, s1, y1, and s2, y2. Next, let's do some example. Find the distance between points. So first point here is -1, 2. Second point is 5, -6. In general, we call the first point s1, y1. In general, we call the first point s1, y1 Call the second point S2, Y2. Then plug into this formula. D equal to x2 minus s1 squared. So I get 5 minus -1 squared. Y2 minus y1. 5 minus -1 squared. Plus y2 minus y1. -6 minus 2 squared. Then simplify. In the parentheses, 5 minus -1. 5 minus -1. Double negative is positive. 5 plus 1 is 6. 6 squared. Plus -6 minus 2. Consider -6 plus -2. Now when adding two numbers of the same sign, keep the sign and the value. I got -8 squared. 6 squared is 36. -8 squared is 64. 36 plus 64 is 100. 36 plus 64 is 100. Square root of 100 is 10. So that's the distance between these 2 points. Next example. We have 2 points, 3, 6, 8, -6. In general, we call the first point S1, Y1. We call the second point S2, Y2. And then apply the distance formula. The formula says S2 minus S1, A minus 3 squared, plus Y2 minus Y1, -6 minus 6 squared. A minus 3 is 5, so I get 5 squared minus plus. In the second parenthesis, -6 minus 6, think of -6 plus -6. When we're adding two numbers with the same sign, keep the sign and the magnitude. 6 plus 6 is 12. 5 squared is 25. -12 squared is 144. 25 plus 144 is 169. Square root of 169 is 13. That's the distance between these 2 points. Next example. 1, 3, 5, -5. In general, we call the first point S1, Y1. We call the second point S2, Y2. Then use distance formula. Distance formula is S2 minus S1 squared plus Y2 minus Y1 squared. Simplify. 5 minus 1 is 4. I get 4 squared plus -5 minus 3. Think of -5 plus -3. -5 plus -3. When we're adding two numbers of the same sign, keep the sign and the value and the magnitude. 5 plus 3 is 8. Then 4 squared is 16. 8 squared is 64. I get square root of 80. How do we simplify square root of 80? For square root of 80, think of this way. First of all, try to find a perfect square factor for square root of 80. Perfect square factor means 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100. These numbers are called perfect squares. So try to find a perfect square factor for 80. Does any of these numbers goes into 80? Here we can see that 16 goes into 80 exactly 5 times. 16 goes into 80 exactly 5 times. Square root of 16 is 4. Square root of 5, we leave it the way it is. So square root of 80 can be written as 4 times square root of 5. So square root of 80 is 4 times square root of 5. That's the distance between these 2 points. Next example. Find the distance between these 2 points. First point, -4, 5. Second point, -1, -1. In general, we call the first point S1, Y1. We call the second point S2, Y2. Then plugging the point into the distance formula. Distance formula says S2 minus S1 squared plus Y2 minus Y1 squared. In the first parenthesis, -1 minus -4. Double negative is positive. -1 plus 3 is 2. I get 2 squared. Second parenthesis, -1 minus 5. Consider this as -1 plus -5. -1 plus -5 is -6. I get -6 squared. 2 squared is 4. -6 squared is 36. 4 plus 36 is 40. How do we simplify square root of 40? 40 is not a perfect square. How do we simplify square root of 40? For square root of 40, think of a perfect square factor. Does any of these numbers go to 40 evenly? The only possibility here is 4. The only possibility is 4. 4 goes to 40 10 times. Square root of 4 is 2. Square root of 10 is not perfect square. We leave it the way it is. So square root of 40 is 2 square root of 10. Next, the distance between these 2 points. Next example. Determine whether the following points are vertices of the right triangle. If yes, graph a right triangle. So, in order to determine whether 3 points are vertices of the right triangle, what should we do? We try to find the distance between the points first. If the distance between the points satisfies Pythagorean theorem, if the distance between these 3 points satisfies Pythagorean theorems, then we can say these 3 points are vertices of the right triangle. Otherwise, they are not vertices of the right triangle. So let's first of all find the distance between the points first. Here we have 3 points. Let me call the first point P, call the second point Q, call the third point R. Let's first of all find the distance between point PQ first. Let's first of all find the distance between point PQ first. For distance between point PQ, let me call the first point S1, Y1, call the second point S2, Y2. Then use distance formula. Distance formula says S2 minus S1 square plus Y2 minus Y1 square. Simplify. That's 2 minus -2. Double negative is positive. 2 plus 2 is 4. I get 4 square. A minus 1 is 7. So I get 7 square here. 4 square is 16. 7 square is 49. 16 plus 49 is 65. Square root of 65 cannot be reduced, so we leave it the way it is. Next, distance between point PQ. Next, let's find distance between point PR. For distance between point PR, only look at point P and point R. So ignore Q for now. Only look at point P and point R. For distance between point PR, we call the first point S1, Y1. Call this point S2, Y2. We're only looking for distance between points P and R. We temporarily ignore point Q. Then apply distance formula. Use x2 minus s1, negative 4 minus negative 2 square, plus y2 minus y1 square. Then simplify. Negative 4 minus negative 2. Double negative is positive, so you get negative 2 plus 4, which is negative 2 square, plus 5 minus 1 is 4. I get 4 square here. Then simplify. Negative 2 square is 4. 4 square is 16. Square root of 4 plus 16 is square root of 20. 4 plus 16 is 20. Can we reduce square root of 20? For square root of 20, think of a perfect square factor. The only factor here for 20 is 4. 4 goes into 20 exactly 5 times. Square root of 4 is 2. Square root of 5 I can leave it the way it is. So that's 2 square root of 5. So square root of 20 is 2 square root of 5. Next, we find the distance between points Q and R. P, Q, R. We first of all find distance between PQ, then distance between PR, and then find distance between QR. Distance between points QR. Only consider point Q and R. For distance between point QR, only consider Q and R. Let's call this point S1, Y1. Call this point S2, Y2. And then use distance formula. Use distance formula. X2 minus S1 plus Y2 minus Y1. Then simplify. Negative 4 minus negative 2. That's negative 6. 5 minus 8 is negative 3. Negative 6 square is 36. Negative 3 square is 9. 36 plus 9 is 45. Can we reduce square root of 45? Square root of 45. Can we find a perfect square factor here for 45? It looks like 9 is a factor of 45. 9 goes into 45 exactly 5 times. Square root of 9 is 3. Square root of 5 cannot be reduced. I leave it the way it is. So square root of 45 is 3 square root of 5. Next, let's check. Let's try to verify Pythagorean theorem. Let's try to verify Pythagorean theorem. For Pythagorean theorem, let's first of all square each side. For Pythagorean theorem, let's first of all square each side. Distance of PQ square, what do we get? Distance of PQ square, I get square root of 65 square. Square cancel square root, I get 65. Next, let's compute distance between point PR. Distance of PR square, what do we get? I get 2 square root of 5 square. 2 square is 4. Square root of 5 square is 5. 2 square is 4. Square root of 5 square is 5. Square cancel square root. Square root of 5 square is 5. 4 times 4 is 20. Then for distance between QR, if I square the side, I get 3 square root of 5 square. 3 square is 9. square root of 5 square. Well, square root of 5 square, square cancel square root, I get 5. 9 times 5 is 45. So here we can check. 20 plus 45 is 65. 20 plus 45 is 65. So we know that distance PR square plus distance QR square equal to distance PQ square. So it satisfies Pythagorean theorem. 20 plus 45 is 65. 20 plus 45 is 65. So it satisfies Pythagorean theorem. The distance between the points satisfies Pythagorean theorem. Means these 3 points, they are vertices of a right triangle. So yes. They are vertices of a right triangle. Since the distance between the points satisfies Pythagorean theorem, they are vertices of a right triangle. Now next, let's graph the right triangle. That's the x-axis, that's the y-axis. Number in the middle is 0. Number to the right are positive. Number to the left are negative. Number above 0 are positive. Numbers below 0 are negative. Let's plot the points. First point, negative 2, 1 is here. That's first point. Second point, 2, 8. X coordinate is 2, Y coordinate is 8, is here. Third point, negative 4, 5. X coordinate is negative 4, Y coordinate is 5. So here we can see that if we want a right triangle, that's a right triangle. That's the point negative 2, 1. That's the point 2, 8. And that's the point negative 4, 5. If we want a right triangle. Next example. Determine whether these 3 points they are vertices of a right triangle. Same thing. Let's try to find the distance between the points. Let's call the first point P. Second point Q. Third point R. We try to find distance between the points. Let's first of all find distance between point PQ. For distance between point PQ, let's call the first point S1, Y1. Call the second point S2, Y2. Then use distance formula. Distance formula says S2 minus S1 square plus Y2 minus Y1 square. Then simplify the expression. Negative 2 minus negative 4 is negative 6. Again, negative 6 square plus 3 minus negative 1. Double negative is positive. 3 plus 1 is 4. So I get 4 square here. Negative 6 square is 36. 4 square is 16. 36 plus 16 is 52. Now, can we reduce 52? For 52, can we find a perfect square here for 52? Can we find a perfect square factor? It looks like 4 works. 4 is a factor of 52. 4 goes to 52 is actually 13 times. Square root of 4 is 2. Square root of 13 is irreducible, even though it is. 13 cannot be reduced. leave it the way it is. So square root of 52 is 2 square root of 13. Next, find distance between point PR. Find distance between point PR. For distance between point PR, only look at point P and point R. Let's call the first point S1, Y1. Call the second point S2, Y2. Apply distance formula. That's square root of S2 minus S1 minus Y2 minus Y1. Simplify. 2 minus 4 is negative 2. It should be addition in the middle. 5 minus negative 1. Double negative is positive. 5 plus 1 is 6. Here, negative 2 squared is 4. 6 squared is 36. I get square root of 40. And we know that square root of 40 can be rewritten as 2 square root of 10. Next, find distance between points Q and R. For distance between points Q and R, only look at point Q and R. Ignore point P. Temporarily ignore point P. Only look at point Q and R. So let me call the first point S1, Y1. Call the second point S2, Y2. Plug into the distance formula. S2 minus S1, I get 2 minus negative 2 square. Y2 minus Y1, I get 5 minus 3 square. 2 minus negative 2, double negative is positive. 2 plus 2 is 4. I get 4 square. Plus 5 minus 3 is 2, so I get 2 square. 4 square is 16. 2 square is 4. 16 plus 4 is 20. Square root of 20 can be reduced as 2 square root of 5. That's the distance between the points. Next, let's try to verify Pythagorean theorem. Pythagorean theorem says c squared equal to a squared plus b squared. So we try to square each side. Square each side first, and then check Pythagorean theorem. Square each side first, and then check Pythagorean theorem. Let me first of all square distance between point PQ. That's 2 square root of 13 square. 2 square is 4. Square root of 13 square. Square cancel square root, I get 13. 4 times 13 is 52. Usually imagine this number here. Imagine this number under square root. Same thing. Distance between point PR. Square. That's 2 square root of 10 square. 2 square is 4. Square root of 10 square. Square cancel square root, I get 10. 4 times 10 is 40. That's the distance of PR square. Usually this number match this number under square root. Next, find distance QR square. That's 2 square root of 5 square. 2 square is 4. Square root of 5 square. Square cancel square root, I get 5. 4 times 5 is 20. Usually imagine this number here under square root. Then let's check. 20 plus 40 is not 52. Here we can see that 20 plus 40 is not 52. so it doesn't satisfy Pythagorean theorem. So here we know dpq square doesn't equal to distance pr square plus distance qr square. It doesn't satisfy Pythagorean theorem, so no. These 3 points, they are not vertices of a right triangle. They are not vertices of a right triangle. They are not vertices of a right triangle. We can verify an answer. Let's plot points. We can verify. These 3 points, they are not vertices of a right triangle. Zero in the middle, number to the right are positive. Number to the left are negative. Number above 0 are positive. Number below 0 are negative. First point is 4, negative 1. X coordinate is 4, Y coordinate is negative 1 is here. Second point is negative 2, 3. X coordinate is negative 2, Y coordinate is 3. Third point is 2, 5. X coordinate is 2, Y coordinate is 5. Here you can see that they don't form a right triangle. These 3 points, they don't form a right triangle. So they are not vertices of a right triangle. Next, let me introduce graph of an equation. In general, an equation with only 2 unknowns, x and y, can represent a graph in the xy plane. For example, 2x plus y equal to 9. X squared equal to y cubed plus 1. Y equal to 2x squared. X squared plus y squared equal to 10. Those are equations with 2 unknowns. All these equations can represent a graph in the xy plane. For a given equation, if a point x and y satisfies it, then we say this point lies on the graph of the equation. And the set of all points which satisfies the equation is the graph of the given equation. Next, let me show you some simple example. For each of the following points, determine whether it lies on the given equation. First example, y equal to 2x squared plus 1. That's the equation of 2 unknowns. And we have 2 points here. We try to verify, we try to determine whether the point lies on the equation, lies on the graph of an equation. So let's verify the first point. First point is negative 1, 3. The first value is the x coordinate. The second value is the y coordinate. So we plug in x and y into the equation to check if the left side equal to the right side. We plug in left side and right side into the equation to check if they are the same. If I plug in x and y, what do I get? Y is 3. I get 3 equal to 2 times negative 1 squared plus 1. I plug in negative 1 for x. I plug in 3 for y. I want to check if this point makes the equation true. If this point makes the equation true, then we say this point satisfies the equation. So this point lies on the graph of an equation. Let's check. Left side stays the same. On the right side, negative 1 squared is 1. 2 times 1 is 2. 3 equal to 2 plus 1. That's true. So this point satisfies the equation. If this point satisfies the equation, this point lies on the graph of the equation. It lies on the graph of an equation. Let's check the second point. Second point, 2, 7. In a point here, first value represents x coordinate, second value represents y coordinate. We try to plug in x and y to see if this point satisfies the equation. If this point satisfies the equation, we say this point lies on the equation. Otherwise, it doesn't lie on the equation. It doesn't lie on the graph of an equation. Let's plug in. We plug in 2 for x, plug in 7 for y. So if I plug in, I get 7 equal to 2 times 2 squared plus 1. We try to verify, is this equation true or not? So left side stays the same. On the right side, 2 squared is 4. We try to verify, is this true or not? Here, 2 times 4 is a. 7 equal to a plus 1. This is not true. 7 equal to a plus 1. This is not true. So this point doesn't satisfy the equation. The point 2, 7 doesn't satisfy the equation. Y equal to 2x squared plus 1. And it doesn't lie on the graph. Since it doesn't satisfy, it doesn't lie on the graph. Next example. The equation is x squared plus y squared equal to 10. And there are 2 points. 2, 4 and -1, -3. Let's check where the point lies on the graph of an equation. Let's check the first point first. First point is 2, 4. For any given point, the first value represents x coordinate. The second value represents y coordinate. We plug x and y into the equation to see if it satisfies the equation. So I plug in 2 for x, I plug in 4 for y. If I plug in 2 for x, I get 2 squared plus, if I plug in 4 for y, I get 4 squared equal to 10. We try to verify, is this true or not? 2 squared is 4. 4 squared is 16. 4 plus 16 equal to 10. That's not true. So the point 2, 4 doesn't satisfy the equation. It doesn't satisfy the equation x squared plus y equal to 10. And it doesn't lie on the graph. Since it doesn't satisfy the equation, it doesn't lie on the graph. It doesn't lie on the graph of an equation. Another point, Another point is -1, comma -3. Does this point satisfy the given equation? Let's check. For any given point, the first number represents x coordinate, the second number represents y coordinate. We plug x and y into the equation. I get -1 squared plus -3 squared. I plug in -1 for x, plug in -3 for y. We try to check. Does this equal to 10? On the left side, -1 squared is 1. -3 squared is 9. We get 1 plus 9 equal to 10. That's true. So this point satisfies the equation. So the point -1, comma -3 satisfies the equation. X squared plus y equal to 10. If we satisfy the equation, this point lies on the graph of the equation. It lies on the graph of the equation. Next, let's look at some different examples. Graph each of the following equations. First equation, y equal to x cubed minus 4x. In order to graph the equation, we try to find all points that satisfy this equation. So we can make a table. Let's make a table for x and y. Here we can try to plug in some value for x and then solve for y. Plug in some value for x. I can plug in some positive value and some negative value. Here we can try -2, -1, 0, 1, and 2. Plug in some positive and negative value for x, and then solve for y. If I plug in x equal to -2, what's y? Y equal to -2 cubed minus 4 times -2. -2 cubed is -a. -4 times -2 is +a. -a plus a is 0. So when x is -2, y is 0. Next, I plug in -1 for x. Plug in -1 for x, solve for y. Y is -1 cubed minus 4 times -1. -1 cubed is -1. -4 times -1 is +4. -1 plus +4 is 3. So when x is -1, y is 3. Next, plug in 0. When x is 0, what's y? Y equal to 0 cubed minus 4 times 0. 0 cubed is 0. 4 times 0 is also 0. 0 minus 0 is 0. So when x is 0, y is 0. Next, plug in 1. When x is 1, what's y? If I plug in 1 for y, if I plug in 1 for x, y equal to 1 cubed minus 4 times 1. 1 cubed is 1. 4 times 1 is 4. 1 minus 4 is -3. So when x is 1, y is -3. Next, plug in 2 for x. Plug in 2 for x, solve for y. Y equal to 2 cubed minus 4 times 2. 2 cubed is a. 4 times 2 is a. A minus a is 0. So when x is 2, y is 0. Then plot points. Based on this table, plot points. This is x-axis. That's the y-axis. 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. First point, negative 2, comma 0. X is negative 2, y is 0. X is negative 2, y 0 is here. That's the first point. Next point, x is negative 1, y is 3. X is negative 1, y is 3. The point is here. That's the second point. X is negative 1, y is 3. Third point, x is 0, y is 0. X is 0, y is 0. Point is here. That's the third point. Next point, 1, negative 3. X is 1, y is negative 3. X is 1, y is negative 3 is here. X is 1, y is negative 3 is here. Next point, x is 2, y is 0. Point is here. X is 2, y is 0. Then connect these points. Connect the points from left to right using smooth curves. Connect the points from left to right using smooth curve. Connect the point using smooth curve. Connect the points using smooth curve from left to right. And remember, the point doesn't end here. X could be negative 3, negative 4, negative 5. So the curve continues. Extend the curve. From the same path, extend the curve. Same thing on the other side. X could be 3, 4, 5. So extend the curve. Follow the same path, extend the curve. The curve doesn't stop here. You need to extend the curve. X could be 3, 4, 5. So there are more points. You need to extend the curve. That's the graph. Y equal to x cubed minus 4x. Next example. Graph the equation. S equal to 1 minus y squared. Graph the equation s equal to 1 minus y squared. Same thing. In order to graph the equation, we need to find out all points. We need to find all points that satisfy this equation. We need to find all points that satisfy this equation. So make table. Make table for x and y. In this equation here, you can see that the expression of x looks simpler. So if I pick value for y and then solve for x, it will be easier. If I pick value for y and then solve for x, it will be easier. Because the expression for x is easier. So here I pick value for y and then solve for x, it will be easier. If I can pick some positive and negative value for y. I can pick negative 2, negative 1, 0, 1, and 2. Here I pick some value for y and then solve for x, it will be easier. If I pick value for x and solve for y, it's okay, but it's very complicated. For example, if I let s equal to 3, solve for y, it's not easier, right? But if I pick value for y, solve for x, it will be easier. If I plug in negative 2 for y and then solve for x, it's easier. So in this situation, plugging value for x, solve for y is harder. But plugging value for y, solve for x is easier. So here I pick value for y and then solve for x. In the previous example, if I pick value for y, solve for x is okay, but it's very complicated. So to make it easier, I pick value for x and then solve for y. That's easier. We can always choose the easier way to plot points. When we plot point, we can pick value either for x or y. Either way is okay. Whichever is easier. So here we pick value for y, then solve for x. When y equal to negative 2, x equal to 1 minus negative 2 square. Negative 2 square is 4. One minus 4 is negative 3. So when y equal to negative 2, x is negative 3. When y equal to negative 1, s equal to 1 minus negative 1 square. Negative 1 square is 1. 1 minus 1 is 0. So when y is negative 1, s is 0. Next, I plug in 0 for y. When y is 0, s equal to 1 minus 0 square. 1 minus 0 square is 1. So when y is 0, s is 1. Next, plug in y equal to 1. When y equal to 1, s equal to 1 minus 1 square. 1 square is 1. 1 minus 1 is 0. So when y equal to 1, s is 0. Next, when y equal to 2, we plug in 2 for y. Solve for x. S is 1 minus 2 square. 2 square is 4. 1 minus 4 is negative 3. So when y is 2, x is negative 3. When y is 2, s is negative 3. Then, once we know the points, we can plot the point and sketch the graph. Next, plot the points. This is an x-axis. That's the y-axis. We have 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then plot points. First point, negative 3 comma negative 2. S is negative 3, y is negative 2. That's our first point. Second point, 0 comma negative 1. S is 0, y is negative 1. S is 0, y is negative 1. Next point, 1 comma 0. S is 1, y is 0. S is 1, y is 0. Next point, S is 0, y is 1. S is 0, y is 1. Next point, x is negative 3, y is 2. S is negative 3, y is 2 is here. Then connect the points. Connect the points using smooth curve. In general, we need to extend the curve. Don't stop here. We need to extend the curve. Extend the curve. Follow the same path. Extend the curve. That's the graph of this equation. Next example. Two x plus y equal to 7. Next example, 2x plus y equal to 7. So, in order to graph an equation, we need to find all points that satisfy this equation. In general, we make table. Make table for x and y. So plot some values for either x or y. We can either plot x or y, whichever is easier. So here it looks like y looks simpler. X has a coefficient, y looks simpler. So if x looks more complicated, we plug a value for x. In general, if here y looks more complicated, if y looks more complicated, plug some value for y. If x looks more complicated, plug some value for x and then solve for y. In this example, x looks more complicated, so plug some value for x and then solve for y will be easier. So here I pick x to be -2, -1, 0, 1, and 2. Then solve for y. When x is -2, plugging -2 for x, I have 2 times -2 plus y equal to 7. 2 times -2 is -4. Plus y equal to 7. And then solve for y. I can add 4 to both sides. I get y equal to 11. So when s is -2, y is 11. Next, plugging s equal to -1. When s is -1, I get 2 times -1 plus y equal to 7. 2 times -1 is -2. Then I can add 2 to both sides. I get y equal to 9. So when s is -1, y equal to 9. Next, when s is 0, I plug in 0 for x and solve for y. I get 2 times 0 plus y equal to 7. 2 times 0 is 0. And we know that 0 plus y is y. So we get y equal to 7. When s is 0, y equal to 7. Then next we plug in 1 for x. When s is 1, I get 2 times 1 plus y equal to 7. 2 times 1 is 2. I get 2 plus y equal to 7. Then I can subtract 2 from both sides. I get y equal to 5. So when s is 1, y is 5. Next, plug in 2 for x. When s is 2, I get 2 times 2 plus y equal to 7. 2 times 2 is 4. I get 4 plus y equal to 7. Then I can subtract 4 from both sides. I get y equal to 3. So when s is 2, y is 3. Then plot these points. That's the x-axis. That's the y-axis. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Here, y could be 11. We need to go up to 11. Then plot points. When s is -2, y is 11. When s is -2, y is 11 is here. That's the first point. Second point, when s is -1, y is 9. It's here. When s is -1, y is 9. Next, when s is 0, y is 7. When s is 0, y is 7 is here. Next, when s is 1, y is 5. When s is 1, y is 5. Next, when s is 2, y is 3. Then connect these points. That's a graph for this equation. Next, let me introduce the x and the y-intercepts. We know that, in general, when we sketch a graph for equation, the graph in general will go through x-axis and y-axis. In general, the graph will touch x-axis and y-axis. The intersection in the x-axis They are called the x-intercepts. And the intersection in the y-axis is called the y-intercept. So the intersection of a graph in the x-axis is called the x-intercept of the graph. And the intersection of the graph in the y-axis is called a y-intercept. Of the graph. So the intersection in the x-axis is called x-intercept. Intersection in the y-axis is called y-intercept. So that's how to define x and y-intercepts. Note, the x-intercept x-intercept always lie on the x-axis. Or x-intercept always lie on the x-axis, and we know that for all points on the x-axis, its y-coordinate must be 0. So its y-coordinate must be 0. Its y-coordinate is always 0. Our x-intercept always lie on the x-axis, and we know that for all points lie on the x-axis, its y-coordinate must be 0. That's what we learned in the beginning of the class. For all points lie on the x-axis, its y-coordinate must be 0. And similarly, a y-intercept always lie on the y-axis. So its x-coordinate must be 0. Its x-coordinate is always 0. For all points in the y-axis, their x-coordinate must be 0. So for x-intercept, its y-coordinate is always 0. And for y-intercept, its x-coordinate is always 0. It's the opposite. For x-intercept, its y-coordinate is always 0. And for y-intercept, its x-coordinate is always 0. It's an opposite. Next, let's look at some simple example. For each of the following equations, find the x and y-intercepts in its graph. For each of the following equations, find the x and y-intercepts in its graph. First example, 2x plus 3y equal to 12. How do we find the x and y-intercepts on the graph of this equation? So we know that for any x-intercept, its y-coordinate must be 0. So for x-intercept, we set y equal to 0. For x-intercept, for any x-intercept, its y-coordinate must be 0. So for x-intercept, we set y equal to 0. Plug in 0 for y, solve for x. I get 2x plus 3 times y equal to 12. I plug in 0 for y, solve for x. Here I get 2x plus 0 equal to 12. So 2x equal to 12. Then I can divide both sides by 2. I get s equal to 6. So the s-intercept is 6, 0. S-intercept is 6, 0. S-coordinate is 6, y-coordinate is 0. For the y-intercept, we know that for any y-intercept, its s-coordinate must be 0. For y-intercept, its s-coordinate must be 0. So for y-intercept, I set s equal to 0. Plug in 0 for x, and then solve for y. I get 2 times 0 plus 3y equal to 12. Plug in 0 for x, then solve for y. Here, 2 times 0 is 0. 0 plus 3y equal to 12. And then 0 plus 3y is 3y. 3y equal to 12. Next, I can divide both sides by 4. I divide both sides by 3. Here, 3 divided by 3 can cancel on the left side. On the right side, 12 divided by 3 is 4. So y-intercept is 4. For the y-intercept, s-coordinate is 0. Y-coordinate is 4. For the y-intercept, s-coordinate is 0. Y-coordinate is 4. That's how we find s and y-intercepts. Next example. Y equal to 9 minus x squared. Find the x and y-intercepts. So, very similar. For s-intercept, set y equal to 0. For s-intercept, set y equal to 0. Plug in 0 for y, and then solve for x. I get 0 equal to 9 minus x squared. Here I can add x squared to both sides. If I add x squared to both sides, I get x squared equal to 9. If x squared is 9, I can take square root on both sides. So s equal to plus or minus 3. I can take square root on both sides. So s equal to plus or minus 3. Here s has two values, positive 3 and negative 3. That means there are two solutions, s equal to 3 and s equal to negative 3. So there are two s-intercepts. For s-intercept, we have 3, 0. S is 3, y is 0. And negative 3, 0. When x is 3, y is 0. When x is negative 3, y is also 0. So here we have two x-intercepts. And similarly, for the y-intercept, set s equal to 0. For the y-intercept, set s equal to 0. Plug in 0 for x and then solve for y. Here I get y equal to 9 minus 0 squared. 0 squared is 0. 9 minus 0 is 9. So the y-intercept here the y-intercept is 0, 9. S coordinate always come first. S coordinate always come first, and then y. S coordinate always come first, and then y. S come first, then y. When we write a point, S coordinate must always come first. Next, x over 4 plus y over 6 equal to 1. Find s and y intercepts for this equation, for the graph of this equation. So, for s-intercept, we set y equal to 0. Plug in 0 for y, and then solve for x. I get x over 4 plus 0 over 6 equal to 1. We know that 0 over 6 is 0. X over 4 plus 0 is s over 4. Then, here, I can multiply both sides by 4. If I multiply both sides by 4, I get s equal to 4. I try to get s by itself, so I multiply both sides by 4. 4 on the left side will cancel this 4 on the bottom, and 4 on the right side. 4 times 1 is 4. So, the s-intercept is 4, 0. S-intercept here is 4, 0. For any point, s-coordinate must come first. We must always run s-coordinate first. For the y-intercept, we usually set s equal to 0, then solve for y. For y-intercept, set s equal to 0, solve for y. If I plug in 0 for x, I get 0 over 4 plus y over 6 equal to 1. Here, 0 over 4 is 0 plus y over 6 equal to 1. And we know that 0 plus y over 6 is y over 6. Then here, I try to get y by itself. That means I need to cancel 6 on the bottom. So I can multiply both sides by 6. If I multiply both sides by 6, then 6 will cancel 6 on the bottom. And here, 1 times 6 is 6. So y equal to 6. That's the y-intercept. So for the y-intercept, write s-coordinate first. For the y-intercept, s-coordinate is 0. Y-coordinate is 6. That's the y-intercept. S-coordinate is 0. Y-coordinate is 6. Next example. X minus 3 squared plus y plus 5 squared equal to 34. Find the x and y intercepts. So, very similar. For the x-intercept, set y equal to 0. So plug in 0 for y. I have x minus 3 squared plus 0 plus 5 squared equal to 34. Here we have x minus 3 squared plus 0 plus 5 is 5. 5 squared is 25 equal to 34. 0 plus 5 is 5. 5 squared is 25. Then I can subtract 25 from both sides. Here I get x minus 3 squared equal to 34 minus 25 is 9. Next, I can take square root on both sides. if I take square root on both sides, x minus 3 equal to plus or minus 3. 3 times 3 is 9. So if I take square root, x minus 3 equal to plus or minus 3, which means there are two cases, x minus 3 equal to 3 or x minus 3 equal to negative 3. Plus minus 3 means it could be either positive 3 or negative 3. Then we solve both equations individually. For the first equation, I add 3 to both sides. I get s equal to 6. For the second equation, I also add 3 to both sides. I get s equal to 0. So there are two s-intercepts. For s-intercept, we have 6, 0 and 0, 0, 0, 0. X coordinate is 0, y coordinate is 0. Those are the s-intercepts. For the y-intercept, do the same thing. We set s equal to 0. For y-intercept, set s equal to 0. Plug in 0 for x, and then solve for y. If I plug in 0 for x, I have 0 minus 3 squared plus y plus 5 squared equal to 34. Here, 0 minus 3 is negative 3. Negative 3 squared is 9. 0 minus 3 is negative 3. Negative 3 squared is 9. Plus y plus 5 squared equal to 34. Next, I can subtract 9 from both sides. If I subtract 9 from both sides, I get y plus 5 squared equal to 25. Then I can take square root. Next, I can take square root on both sides. If I take square root, I get y plus 5 equal to plus or minus 5. If I take square root here, I get plus or minus 5. Which means there are two cases. Either y plus 5 is 5 or y plus 5 is negative 5. There are two cases. Y plus 5 could be either positive 5 or negative 5. Then solve for x, solve for y. In the first equation, I can subtract 5 from both sides. If I subtract 5 from both sides, I get y equal to 0. For the second equation, I can subtract 5 from both sides. If I subtract 5 from both sides, I get y equal to negative 10. Negative 5 plus negative 5 is negative 10. So we have two y-intercepts. For y-intercept, we must write s coordinate first. For all points, we must write s coordinate first. So the first point is 0, 0. Second point is 0, negative 10. S coordinate always come first. 0, negative 10. So those are the s-intercept, those are the y-intercept. Next, let me introduce circle. How do we define a circle? We know that in general, if we want to draw a circle, we must know the center of a circle, called O. And we must know the radius of a circle. We must know the radius of a circle, called R. Then, the set of all points where the distance from the point to the center equal to R form a circle. The set of all points where the distance from the point to the center equal to R form a circle. So that's how we define a circle. So to define a circle, let O equal to h, k. That's the coordinate of the circle, of the center of a circle. Let O equal to h, k be a point in the xy plane. So O is a point. H, k is the coordinate of the point O. Let O be a point in the xy plane. And let R be a positive real number. radius must be positive. Let R be a positive real number. The set of all point P whose coordinate is x, y. The set of all point P with distance from O to P equal to R. The set of all point P with distance from OP equal to R form a circle in the xy plane. The set of all point P with distance from OP, DOP means distance from OP equal to R. The set of all point P with distance between OP equal to R form a circle in the xy plane. Next, let me try to derive a formula for a circle. We know that P has a property that distance from between OP equal to R. How do we find equation for this? How do we find a formula for a circle? How do we find distance OP? How do we find distance between O and P? The coordinate of O is h, k. The coordinate of P is x, y. For distance between 2 points, let me call the first point S1, Y1. Call the second point S2, Y2. That equal to square root of S2 minus S1, x minus h squared, plus Y2 minus Y1, y minus k squared. And we know that distance between OP is R. Distance between points O and P is R. So we have R equal to square root of x minus h squared plus y minus k squared. Then if I square both sides, if I try to make it simpler, I can square both sides. If I square both sides, I get R squared equal to x minus h squared plus y minus k squared. This equation can be rewritten as x minus h squared plus y minus k squared equal to R squared. That's the equation of a circle. That's the equation of a circle. So equation of a circle. The equation in the form of s squared minus equation in the form of x minus h squared plus y minus k squared equal to R squared represent a circle in the xy plane. Whose center is the point h, k. And radius is R. Equation in this form represents a circle in the xy plane. And h, k represent the center of a circle. And radius r represents radius of the circle. So keep this in mind. That's the equation of a circle. Next, let's look at some examples about circle. Graph each of the following circles. First example, x minus 2 squared plus y plus 3 squared equal to 4. In order to graph a circle, we must know the center and the radius. Equation of a circle is always x minus h squared plus y minus k squared equal to r squared, where the center is the point h comma k, and the radius is r. First step, try to match the equation. Find the center and radius. First step, try to match the equation. Find the center and radius. What's the center here? What's the center of a circle? If we try to match the formula here, we can see that both h and k has negative sign in the front. Both h and k has negative sign in the front. So for h and k, for the center, we must take opposite value. For the center, we must pick opposite value. If the number here is negative 2, we pick positive 2 from the center. If the number here is positive 3, we pick negative 3. Because for h and k, they both have negative sign in the front. So we must pick opposite, we need to pick opposite value. If this number is negative, use the positive value. If this number here is positive, use negative value. So that's the center of a circle, 2 comma negative 3. For the center, use the opposite value for x and y. Then, what's the radius? If we try to match the formula, we can see that r squared equal to 4. If we try to match the formula, we can see that r squared equal to 4. If r squared is 4, then r must be 2. If we try to match the formula, we can see that r squared is 4. If r squared is 4, then r must be 2. So that's the center, that's the radius. Next, let's graph the circle. That's the x-axis. That's the y-axis. 0 in the middle. The number to the right are positive. Number to the left are negative. Number above 0 are positive. Number below 0 are negative. Then we plot the center first. In order to graph a circle, plot the center first. Center is 2 comma negative 3. X coordinate is 2, y coordinate is 3. That's the center, 2 comma negative 3. Now next, we know that radius of circle is 2. So move 2 units up, move 2 units down, move 2 units to the left, move 2 units to the right. Then connect these 4 points, we can make a circle. Center is here, radius is 2. Move up by 2 units, down by 2 units, 2 units to the left, 2 units to the right. Then connect these 4 points using smooth curve. We can make a circle. Connect these 4 points using smooth curve. We can make a circle. That's the graph of this circle. Next example, x plus 1 squared plus y minus 1 squared equal to 9. Sketch the graph for this circle. First step, we try to match the formula. Try to find out what's the center and what's the radius. First step, try to match the formula, find out what's the center and what's the radius. For the center, we have negative h, negative k. Since both h and k has negative sign in the front, we pick an opposite value for h and k. Pick an opposite value for h and k. We have positive 1 here, so I pick negative 1. I use negative 1. We have negative 1 here. I use positive 1. Since both h and k has negative sign in the front, we must pick an opposite value. Number 1 is positive, we use negative 1. Negative 1 is negative, we use positive 1. That's the center of the circle. Next, the radius. If we try to match the formula, you can see that r squared equal to 9. If we try to match the formula, you can see that r squared equal to 9. If r squared equal to 9, then r must be 3. If r squared equal to 9, r must be 3. We take square root, r must be 3. Radius is always positive, it won't be negative. So r squared equal to 9, r equal to 3. Radius is always positive, it won't be negative. So r squared equal to 9, r equal to 3. That's the radius of a circle. Next, let's graph the circle. That's an x-axis. That's an y-axis. 0 in the middle. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. First step, plot the center of a circle. The center of the circle is -1, 1. X coordinate is -1, y coordinate is 1. That's the center of the circle, Radius is 3. So we move 3 units up. 1, 2, 3. 3 units down. 1, 2, 3. 3 units to the left. 1, 2, 3. And 3 units to the right. 1, 2, 3. Then coordinate is 4 points, we can make circle. Coordinate is 4 points, we can make circle. Coordinate is 4 points, using smooth curve, we can make circle. That's the graph of this circle. Next, graph the equation of a circle. S squared plus y minus 5 squared equals 16. In order to graph a circle, we need to first of all find the center and the radius of the circle by matching the formula. So match the formula, find the center and the radius of the circle. Center is h and k. Here we have x squared. Here we have x minus h squared. If there's no number after x, that means h must be 0. And since h and k, they both have negative sign, we need to take opposite value. Here, k is positive 5. Since we have negative 5 here, k is positive 5. For h and k, since we have negative sign here, we need to take opposite value for both h and k. We have 5, y minus 5. So for k, take an opposite value. K is positive 5. That's the center of the circle. Next, find the radius. Try to match the formula. We know that r squared is 16. R squared is 16. If I take square root, r must be 4. Radius is always positive. So r equal to 4. Radius is 4. Once we know the center and the radius, we can graph the circle. That's the x-axis. That's the y-axis. That's 0. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Here, center is 0, 5. X coordinate is 0, y coordinate is 5. Radius is 4, so go up by 4 units. 1, 2, 3, 4. Go down by 4 units. 1, 2, 3, 4. Go 4 units to the left. 1, 2, 3, 4. Then go 4 units to the right. Go 4 units to the right. 1, 2, 3, 4. Then connect these 4 points using smooth curve. We can make a circle. That's a graph of this circle. Next example, x squared plus y squared equal to 4. In order to graph the circle, first step, try to match the formula. Find the center and radius first. First step, try to match the formula. Find the center and radius. Find the center and radius. If we match the formula here, there's no numbers after x, no numbers after y. If we try to match the formula here, both h and k must be 0. X minus 0 is x. Y minus 0 is y. So both h and k must be 0. If there are no numbers after x and y, both h and k must be 0. So the center is 0, 0, which is an origin. What's the radius? Try to match the formula. R squared must equal to 4. If r squared equal to 4, then r must be 2. Take square root. If r squared is 4, then r must be 2. We take square root. Square root of 4 is 2. Once we know the center and the radius, we can graph the circle. That's an x-axis. That's an y-axis. 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Plot the center first. Center is 0, 0 here at the origin. Radius is 2. So we go 2 units up. 2 units down. 2 units to the left. And 2 units to the right. Then connect 4 points using smooth curves. That's the graph of this circle. Next example. For each of the following equations, show that it represents a circle, and then find center and radius. First example, x squared plus 4x plus y squared minus 6y minus 3 equals 0. We try to show this equation represents a circle. In order to show this equation represents a circle, we must rewrite this equation in the form of x minus h squared plus y minus k squared equal to r squared. In order to show this equation represents a circle, we must rewrite this equation in this form. And then we can find the center and the radius. How can we rewrite this equation in this form? So first step, we try to group x together and group y together. First step, group x together, then group y together. Next, we move the single number to the other side. Add 3 to both sides. Move 3 over. First step, group x together, then group y together. Move the single number to the other side. Next, we try to complete square. We try to add a term here and add a term here to make perfect square for these two terms. Next, try to make perfect square. Try to complete square. X squared plus 4x plus y squared minus 6y equal to 3. We try to add some number here to make this a perfect square, and add some number here to make this a perfect square. The rule is, take a middle number, divide by 2, and then square. The rule here is take a middle number, divide by 2, and then square. Here, the middle number is 4. 4 divided by 2 is 2, and then square. Square this number, 2 squared equal to 4. Take a middle number, divide by 2, and then square. I get 4. Once I get 4, add 4 to both sides. Add 4 to the left, add 4 to the right. Do the same thing for the second parenthesis. Take the middle number. Ignore the positive or negative sign. Take the middle number, which is 6. Ignore the positive or negative sign. Middle number is 6. Take 6 divided by 2. I get 3. Then square this number. 3 squared equal to 9. Take the middle number, which is 6. 6 divided by 2 is 3. 3 squared is 9. Take the middle number, divide by 2, and then square. I get 9. Add 9 to both sides. Add 9 here, and add 9 to the other side. Now, on the left side, what do we get here? On the left side, try to factor this. How do we factor this? How do we factor this? X squared plus 4x plus 4. How do we factor this? Here I can draw two parentheses. X squared can be factored as x times x. Next, try to find two numbers that multiply to be 4 and add to be 4 here. Find two numbers. When we multiply, we get this 4. When we add, we get this 4 here. We can try positive 2 and positive 2. 2 times 2 is 4, and 2 plus 2 is this 4. So put plus 2 in the parentheses. That's how we factor this. So x squared plus 4x plus 4 is x plus 2 times x plus 2, which is x plus 2 squared. So that's the first part. X squared plus 4x plus 4, it can be factored as x plus 2 squared. That's the first part. Second part, y squared minus 6x, y squared minus 6y plus 9. How do we factor this? Y squared minus 6y plus 9. Same thing, try to factor this. Draw two parentheses. Factor y squared, I get y times y. Next, try to find two numbers that multiply to be 9 and add to be negative 6. Find two numbers. When we multiply, we get 9. When we add, we get 6. We get negative 6. We know that 3 times 3 is 9. But we try to get negative 6 here. So I can make negative 3, negative 3. Negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. So negative 3 works. Put in the parentheses. Y minus 3 times y minus 3 is y minus 3 squared. So y squared minus 6y plus 9. If I factor, I get y minus 3 squared. Now, on the right side, add the numbers. 3 plus 4 is 7. 7 plus 9 is 16. Now, this equation looks in this form. Now, try to match. Find the center and radius. Try to match. Find the center and radius. Since both h and k is negative. Since both h and k has negative sign in the front, we take an opposite value. So here, h is negative 2, k is positive 3. Since both h and k has negative sign in the front, we take an opposite value. H here is negative 2, k is positive 3. That's the center. And the radius, r squared is 16. If you try to match, r squared is 16. For r, take square root. Square root of 16 is 4. R is always positive, so it won't be plus minus 4. It's always positive 4. That's the center, that's the radius. Next example. X squared minus 2x plus y squared minus 8y plus 1 equal to 0. We try to show this represents equation of a circle. So first step, we try to group x together, group y together. We try to rewrite this equation in this form. So I first of all group x together, group y together, move from the single number to the other side. So group x together, I get x squared minus 2x plus y squared minus 8y. Then subtract 1 from both sides, move this one over, subtract 1 from both sides. I get negative 1 on the right side. Next, try to complete square. I have x squared minus 2x plus y squared minus 8y equal to negative 1. I try to add some term here, add a term here, add a term here to make a perfect square. What can we do here? Take the middle number, ignore the positive or negative sign. Take the middle number, which is 2. Divide by 2. Take the middle number, divide by 2. I get 1. And then square the number. 1 squared is 1. Take the middle number, divide by 2, I get 1. And then 1 squared is 1. Then add 1 to both sides. Add 1 here, add 1 here. Next, in the second parenthesis, the middle number is a. Middle number is a. Divide by 2, I get 4. And then square this number. 4 squared is 16. Take the middle number, which is a. Divide by 2, I get 4. And then square this number. 4 squared is 16. Add 16 to both sides. Add 16 here, add 16 here. Next, try to factor this. How do we factor x squared minus 2x plus 1? Here I can draw two parentheses. Put x on each parentheses. And then try to find two numbers. When we multiply, we get 1. When we add, we get negative 2. Find two numbers, then multiply to be 1. And the only possibility is 1 times 1. But we try to get negative 2 in the middle. So make it a negative. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So put negative 1 in the parentheses. X minus 1 times s minus 1. That can be rewritten as s minus 1 squared. So that's the first part. I get s minus 1 squared. In the second part, we have y squared minus 8y plus 16. How do we factor this? Y squared minus 8y plus 16. We try to find two numbers. First of all, draw two parentheses. Put y on each parentheses. We try to find two numbers. When we multiply, we get 16. When we add, we get negative a. We know that 4 times 4 is 16. But we try to get negative a here. So I can use negative 4 times negative 4. Negative 4 times negative 4 is 16. And negative 4 plus negative 4 is negative a. So these two numbers works. Put it in the middle. This can be rewritten as y minus 4 squared. Y minus 4 times y minus 4 is y minus 4 squared. So that's y minus 4 squared. On the right side, negative 1 plus 1 is 0. They get cancelled. What's left is 16. Then try to match this equation with this equation here and find h and k. Since both h and k has negative in the front, we take an opposite value. So here h is 1, k is 4. Since both h and k has negative sign in the front, take an opposite value. Here h is 1, k is 4. That's the center. For the radius, try to match. We have r squared equal to 16. R squared equal to 16 means r equal to 4. Take square root. That's the center and radius. Next example. S squared plus 6x plus y squared plus 10y plus 24 equal to 0. S squared plus 6x plus y squared plus 10y plus 24. In order to show this represents equation of a circle, we must rewrite this equation in this form, and then try to match h and k and the radius. So first step, we try to group x and y together. I get x squared plus 6y plus y squared plus 10y. Group x and y together. And then move the single number to the other side. Here I can subtract 24 from both sides. Subtract 24 from both sides, I get negative 24 here. Next, try to complete square. Next, try to complete square. X squared plus 6x. We try to add a term here to make perfect square. Plus y squared plus 10y. I try to add a term here to make perfect square. What should we add to make perfect square? So, take the middle number. It's 6. Divide by 2. I get 3. Then square this number. 3 squared is 9. Take middle number, divide by 2. I get 3. Then square this number. 3 squared is 9. So here I can add 9 to both sides. Add 9 here, add 9 here. For the other equation, do the same thing. Take the middle number, which is 10. Take the middle number, divide by 2. 10 divided by 2 is 5. Then square this number. 5 squared is 25. 5 squared is 25. So add 25 to both sides. Add 25 here. Add 25 to the other side. Then simplify. Let's factor this first. X squared plus 6x plus 9. What do we get? X squared plus 6x plus 9. In order to factor this, I can first of all draw two parentheses. Put x on each parentheses. Then try to factor 9. 9 can be factored as 3 times 3. We know that 3 times 3 is 9, and 3 plus 3 is 6. So these two numbers works. They are both positive. So write positive 3 in the parentheses. We get s plus 3 times s plus 3. That can be rewritten as x plus 3 squared. That's the first term. I get x plus 3 squared. For the second half, do the same thing. Factor this. I get y squared plus 10y plus 25. Put y on each parentheses. Then factor 25. I'm trying to find two numbers. Then multiply to be 25. Add to be 10. Which is 5 times 5. And we know that 5 times 5 is 25. 5 plus 5 is 10. They are both positive. So these two numbers works. I get 5 y plus 5 times y plus 5. This can be rewritten as y plus 5 squared. This can be rewritten as y plus 5 squared. On the other side, adding up. Negative 24 plus 9 is negative 15. Negative 15 plus 25 is positive 10. If we try to match this formula here, since h and k, they both have negative sign in the front, so we must take opposite value for h and k. So the center is negative 3, comma, negative 5. For h and k, we must take the opposite value. Here h is negative 3, k is negative 5. That's the center. What's the radius? How do we find the radius here? If we try to match the formula, we can see that r squared equal to 10. If r squared equal to 10, what's r? For r, we take square root. R equal to square root of 10. R equal to square root of 10. That's the radius. Radius is square root of 10. Next, x squared minus x squared plus 3x plus y squared minus 5y plus a equal to 0. We try to show that This equation represents equation of a circle. In order to show this represents equation of a circle, we try to rewrite the equation in this form. And then we try to match h and k, find the center and the radius. So first of all, we group x together and we group y together. Then move the single number to the other side. Here I can subtract a from both sides. If I subtract a from both sides, I get negative a here. Then we try to make perfect square for the first term and the second term. x squared plus 3x plus y squared minus 5y equal to negative a. We try to add some number here and add some number here to make them perfect squares. What can we do here? Same procedure. Those numbers are not nice, but same procedure. They are not nice, but same procedure. First of all, take the middle number, divide by 2. 3 divided by 2, that's 3 over 2. It cannot be simplified. 3 divided by 2 is 3 over 2. That cannot be simplified. Then leave it the way it is. Square this number. Square this number. 3 over 2 square is 9 over 4. 3 over 2 square is 9 over 4. That cannot be simplified. Leave it the way it is. So take middle number 3 divided by 2. You get 3 over 2. It cannot be simplified. Leave it the way it is. Then square this number. 3 over 2 square is 9 over 4. Add 9 over 4 to both sides. Add 9 over 4 to both sides of an equation. That's the first parenthesis. Do the same thing to the second parenthesis. Do the same thing. Take the middle number. Don't worry about you can only positive or negative sign. Take the middle number, 5 over 2. Take 5 divided by 2. Take the middle number, divide by 2. 5 over 2 cannot be simplified, so I leave it the way it is. Then square this number. 5 over 2 square. If I take 5 over 2 square, I get 25 over 4. 5 over 2 square is 25 over 4. So add 25 over 4 to both sides. Next, try to factor this. How do we factor x squared plus 3x plus 9 over 4? X squared plus 3x plus 9 over 4. How do we factor this? I can first of all draw two parentheses. 2x on each parentheses. Then same procedure. We try to find two numbers. Let multiply to be 9 over 4. Add to be 3. So for 9 over 4, we can use this number. 3 over 2. 9 over 4 can be rewritten as 3 over 2 times 3 over 2. And we know that 3 over 2 times 3 over 2 is 9 over 4. But when we add them, 3 over 2 plus 3 over 2 is 3. 3 over 2 plus 3 over 2 is 6 over 2, which is 3. So we can factor this as x, they are both positive. So it can be factored as x plus 3 over 2 times x plus 3 over 2. That can be rewritten as x plus 3 over 2 square. So this number always match what we have here. We get x plus 3 over 2 square. Next, factor the second parenthesis. Y squared minus 5y plus 25 over 4. Factor y squared minus 5y plus 25 over 4. Do the same thing, draw two parentheses. Put y on each parenthesis. Then we try to find two numbers. That when we multiply, we get 25 over 4. When we add, we get negative 5. We can try this number here. 25 over 4 is obtained from 5 over 2 square. So we can use 5 over 2. 5 over 2 times 5 over 2 is 25 over 4. But when we add them, we get positive 5. 5 over 2 plus 5 over 2 is 10 over 2, which is positive 5. We try to get negative 5 here. So use negative 5 over 2 and negative 5 over 2. When we multiply, we get 25 over 4. When we add, we get negative 5. So put negative 5 over 2 here, negative 5 over 2 here. This can be rewritten as y minus 5 over 2 squared. This number always matches what we have here, 5 over 2. And the plus minus sign depends on what we have originally. So after factoring, we have y minus 5 over 2 squared. That's on the left side. On the right side, negative a plus 9 over 4 plus 25 over 4. How do we add these numbers? Negative a plus 9 over 4 plus 25 over 4. I first want to write negative a as negative a over 1. Then try to make denominator the same. Find a common denominator for 1 and 4. And the common denominator is 4. So I can multiply top by 4, bottom by 4. I get negative 32 over 4 plus 9 over 29 over 4 plus 25 over 4. If I add them up, negative 32 plus 9 is negative 23. Negative 23 plus 25 is positive 2. 2 over 4 can be reduced as 1 over 2. 2 over 4 can be reduced as 1 over 2. So the right side here is 1 over 2. The right side here is 1 over 2. If I add them up, I get 1 over 2 on the right side. Then we can try to match. We can try to match and find h and k. Since h and k they both have negative sign in the front, we must take an opposite value. So here the center is negative 3 over 2 and 5 over 2. That's h, that's k. Since h and k they both contain negative sign in the front, we must pick an opposite value. And what's the radius? What's the radius? Let's match. We have r squared equal to half. If r squared equal to half, what's r? R is square root of 1 over 2. That's r. That's the radius. Square root of 1 over 2. Next example. Find the equation of a circle that satisfies the given information. In order to find the equation of a circle, we must know the center and the radius of the circle, and then put it in the form of x minus h squared plus y minus k squared equal to r squared. This form is also called the standard form of a circle. So, in order to write the equation of a circle, we must know the center and the radius, then put it in the standard form of a circle. So in the first problem, we know the center, we know the radius, so I can directly plug in. If I plug in, I get x minus, here h is 2, k is 3. So I get x minus 2 squared plus y minus 3 squared equal to r. Here r is 5, so equal to 5 squared. And then we know that 5 squared is 25. That's the equation of a circle. Satisfies all given information. That's the equation of a circle. Center at 2, 3 with radius 5. Number 2. Find the equation of a circle. Center at negative 4, 1 with radius vertical 3. So same thing, we plug in. That's h, that's k. Plug in h and k, and that's r. We have x minus negative 4 squared plus y minus 1 squared equal to r squared. Here r is radical 3. Then simplify. Minus minus double negative is positive. I get x plus 4 square plus y minus 1 square. Radical 3 square is 3. That's the standard form of an equation that satisfies this given information. Next, find equation of a circle. Center at the point 2, negative 1. And a point on the circle is negative 1, 3. We try to find equation of a circle. Center at 2, negative 1. And a point on the circle is negative 1, 3. We try to find a circle. Center at a point 2, negative 1. And a point on the circle is negative 1, 3. That's the center, and that's a point on the circle. We try to find the equation of this circle. What can we do here? In order to write equation of a circle in standard form, we must know the center and the radius. Here we know the center already, so all we need is find the radius. How do we find the radius? Radius of circle is always distance from the center to the edge of a circle. Radius of circle is always distance from the center to the edge of the circle. That's the radius. Distance from the center to the edge. So radius is the distance from the point 2, negative 1 to the point negative 1, 3. So for the radius, we find the distance between these 2 points. Then we call the first point S1, S1, Y1. And call the second point S2, Y2. And then use distance formula to find the distance from the center to the edge. So here, S2 minus S1, I get negative 1 minus 2 square plus Y2 minus Y1, 3 minus negative 1 square. Then simplify. Negative 1 minus 2. This can be considered as negative 1 plus negative 2. Negative 1 plus negative 2 is negative 3. So we get negative 3 square plus 3 minus negative 1. Double negative is positive. 3 plus 1 is 4. I get 4 square. Negative 3 square is 9. 4 square is 16. 9 plus 16 is 25. Square root of 25 is 5, so r equal to 5. Equation for circle is x minus h squared. Here h is 2 plus y minus k squared. Here k is negative 1. Plus equal to r squared. Here r is 5. Then simplify. I get x minus 2 squared plus y plus 1 squared equal to 25. That's an equation of a circle that satisfies both given conditions. Next, find equation of a circle. Find equation of a circle. Center at a point negative 3, negative 4. And a point on the circle. A point on the circle is negative 2, 1. Find the equation of a circle. Center at the point negative 3, 4. And a point on the circle is negative 2, 1. So The situation is very similar. Center of the circle is -3, -4. A point on the circle is -2, 1. We try to find the equation of this circle. So in order to write equation of a circle in standard form, we must know the center and the radius. In this problem, we know the center already. The center is -3, -4. Next, we try to find radius. Radius is always the distance from the center to the edge of the circle. Radius is always distance from the center to the edge of the circle. So let's find the distance from the center to the edge using the radius. How do we find distance? We call the first point S1, Y1. Call the second point S2, Y2. Then use the distance formula. Use the distance formula. S2 minus S1. I get -2 minus -3 square plus Y2 minus Y1. 1 minus -4 square. Then simplify. -2 minus -3. Double negative is positive. -2 plus 3 is 1. I get 1 square plus 1 minus -4. Double negative is positive. 1 plus 4 is 5. 1 square is 1. 5 square is 25. 1 plus 25 is square root of 20 is 26. Square root of 26 cannot be simplified, so I leave it the way it is. That's the radius of the circle. Then we know the center, we know the radius. We can run the equation of a circle in standard form. And here we plug in. I get x minus h. H is -3 square plus y minus k. Here k is -4 square equal to r square. Here r is square root of 26 square. Then simplify. Double negative is positive. X minus -3. Double negative is positive. I get x plus 3 square. Y minus -4. Double negative is positive. I get y plus 4 square. And square root of 26 square. Here, square cancel square root. I get 26. That's an equation of a circle that satisfies both given conditions. That's an equation of a circle that satisfies both given conditions. Next, find an equation of a circle where the endpoint of a diameter are 1, 6 and 7, -2. Number 5. Find an equation of a circle that satisfies this condition. This condition says the endpoint of a diameter are 1, 6 and 7, -2. Find an equation of a circle that satisfies this condition. This condition says the endpoints of a diameter is 1, 6 and 7, -2. That's a circle. The endpoint of a diameter is 1, 6 and 7, -2. Find the equation of this circle. Find the equation of a circle where the endpoint of a diameter are 1, 6 and 7, -2. How do we find equation of a circle? In order to write equation of a circle, we must know the center and the radius. How do we find the center here? Once I know the endpoint of a diameter, the center is the midpoint of these two endpoints. Once I know the endpoint of a diameter, the center of the circle is the midpoint of these 2 points, of these two endpoints. So the center is the midpoint. How do we find the midpoint? Let me call the first point S1, Y1. Call the second point S2, Y2. How do we find the midpoint? For the midpoint, we first of all find the average of x, find the average of the s coordinate, and then find the average of the y coordinate. Let's find the average of s coordinate first. S1 plus S2 over 2, what do we get? We get 1 plus 7 over 2. It's a over 2 equal to 4. Next, find the average of the y coordinate. I get y1 plus y2 over 2. That's 6 plus negative 2 over 2. 6 plus negative 2 is positive 4. 4 over 2 is 2. So the center of the circle is 4, 2. The center of the circle is the midpoint of these two endpoints of the diameter. The midpoint of these two endpoints here is the center. That's 4, 2. Next, once I know the center, how to find the radius of the circle? Once we know the center, how to find the radius of the circle? The distance from the center to the edge. Distance from the center to the edge is the radius. Distance from center to the edge of a circle is the radius. Next, for the radius, we try to find the distance from this point to the center. So let me call this point S1, Y1. Call this point S2, Y2. So the radius is square root of S2 minus S1 square. 4 minus 1 square plus Y2 minus Y1 square. 2 minus 6 square. If I simplify here, what do we get? 4 minus 1 is 3. I get 3 square here. 2 minus 6 is negative 4. I get negative 4 square. 3 square is 9. Negative 4 square is 16. 9 plus 16 is 25. Square root of 25 is 5. Here we know the center, we know the radius. We know the center, we know the radius. So we can use this equation to find equation of a circle. So we have x minus h. Here h is 4. Plus y minus k. K is 2. Square plus r equal to r square. Equal to r square. Here r is 5. So we get 5 square. Simplify, we get s minus 4 square plus y minus 2 square equal to 25. That's the equation of a circle. Satisfy this condition. Next, find the equation of a circle that satisfies the condition here. Says endpoints of a diameter are the points negative 2, 1 and a, negative 5. Find the equation of a circle where the endpoint of a diameter are negative 2, 1 and a, negative 5. How do we find the equation of a circle that satisfies this condition here? We know that the endpoint of a diameter is negative 2, 1 and a, negative 5. If we know the endpoint of a diameter, the midpoint of these two endpoints is the center of the circle. If we know the endpoint of a diameter, the midpoint of these two endpoints is the center of the circle. So let's find the midpoint first. The formula for midpoint is s1 plus x2 over 2. The average of the s coordinate, which is -2 plus a over 2. The average of the s coordinate, -2 plus a over 2, which is 6 over 2. 6 over 2 is 3. Next, for the y coordinate, that's the midpoint, that's an average of the y coordinate. Y1 plus y2 over 2. y1 plus y2 over 2, I get 1 plus -5 over 2. 1 plus -5 is -4. -4 over 2 is -2. So the center of the circle is the point 3, -2. That's the center. 3, -2. Next, we try to find the radius of the circle. Radius of the circle is a distance from the center to the edge of the circle. Radius of the circle is a distance from the center to the edge of the circle. That's a radius. So let's find the distance from the center to the edge. The distance formula is always, let me call the first point S1, Y1, second point S2, Y2. The distance formula is always x2 minus s1 square, 3 minus -2 square, plus y2 minus y1 square, -2 minus 1 square. Then simplify. 3 minus -2 is, double negative is positive. 3 plus 2 is 5. I get 5 square here. -1 minus -2 minus 1. Consider this as -2 plus -1. That's -3 square. 25. 5 square is 25. -3 square is 9. 25 plus 9 is 34. Square root of 34 cannot be simplified, so I leave it the way it is. Now here I know the center, I know the radius of a circle. I can write the equation in this form, in the standard form. So I have x minus h. H is 3. Plus y minus k. K is -2. Square equal to r square. R is radical 34. Square. Then simplify. I get x minus 3 square plus y plus 2 square. Double negative is positive. And then square root of 34 square. We know that square cancels square root. I get 34 by itself. That's the equation of a circle whose endpoint of a diameter is these 2 points.